Hi teen, today's lesson looks at how doubling the sides of a geometric shape increases its area by 4 times. Hi teen, this is Chris Abraham from GoMath.com. Let's look at this concept of doubling the sides of geometric shapes. Specifically, we're going to look at rectangles, triangles, and circles. Okay? So let's say we have a rectangle here. And I'm going to draw a triangle here. And let's say we have a circle here with a radius. Let's say the radius is 10. Make our lives nicey nice. Alright, so here are these three shapes. I have a rectangle that's got sides of 2 and 4, a triangle that has sides of 3 and 4, and a circle that's got sides of 10. And for each one of these geometric shapes, I'm going to double the dimensions. Let's see. So this rectangle now I double the dimensions, meaning it has a side of 4 and 8. This triangle, doubling the dimensions, has a side of 6 and 8. And the circle, wow, I'm off the board, it's so big. But the circle has now a radius of 20. Let's start with just focusing in on what happens with this rectangle when we double the sides. When I double the sides, well, for one thing, I increase the perimeter, I double the perimeter. Because right now, currently, it's 2, 4, 2, 4, or this whole thing has a perimeter of 12. But now, when I double the sides, I increase the perimeter to 24. This would be 4, 8, 4, 8. Or the perimeter here is 24. So doubling the sides means I increase the perimeter, I double the perimeter. And we could say doubling, another way of thinking about doubling is when you multiply by 2, you're actually increasing it by 200%. Because you're doubling something, you're increasing it by 200%. Well, area is a little different. Because now the area of this one right here is 8, but the area of this one here is 4 times, its length times width, 4 times 8, or 32. So the area has increased 4 times. So when I increase something 4 times, I'm actually increasing it 400%. So when I double the size of a rectangle, I increase the perimeter by 200%, or double it. And when I double the dimensions of a rectangle, I increase the area by 400%, or quadrupling it. Okay, let's see what happens when we do the same thing to a triangle. Well, guess what? Using the Pythagorean theorem on this right triangle here, I didn't add that in, but I'm going to add that in right now. I'm telling you that they're two right triangles. I could use the Pythagorean theorem, a squared plus b squared equals c squared. I could conveniently find out that this missing side here is going to be 5. And if I did the Pythagorean theorem here, that's 6 squared is 36, plus 8 squared is 64, would equal 100. So what times itself gets 100? That would be 10. By doubling the sides here, I've doubled the perimeter. Whatever the perimeter of a triangle that's 3 by 4 by 5, it's doubled to a new triangle that's 6 by 8 by 10. However, if I find out the area of this, which is, to do that I have to use the area formula of a triangle, 1/2 base times height. 1/2 4 times 3 gets us 6. Well, 1/2 6 times 8 gets us 24. By doubling the lengths of the sides, I've increased the area 4 times. When you double the length, the perimeter increases 200 times, but the area increases 400 times for a rectangle and a triangle. Well, what about a circle? I mean, a circle's a little different. I mean, a circle's a circle. It's circular. I mean, it can't be the same for circles. Well, let's see. What's the formula for the perimeter or the circumference of a circle? That's 2 pi r. So right now, this circumference here is 2 times r. So if r is 10, this is 20 pi. This one right here, since it's already 20 pi, it would actually be 40 pi. So guess what? By doubling this dimension, to a larger circle, I've doubled the perimeter. But let's see what happens with the area of a circle, because maybe that's somehow different than a rectangle and a triangle. Well, what's the formula for the area of a circle? The formula for an area of a circle is pi r squared. So in this case right here, that would be r squared would be 10 squared, which would be 100. So I have 100 pi units squared. And this one right here would be 20 squared. What's 20 squared? 400. And this would have an area of 400 pi, whatever the units squared are. So once again, whether we're dealing with a rectangle, a triangle, or a circle, you double the dimensions, you double the perimeter. You double the dimensions, you quadruple the area. And another way of saying quadruple is the smaller shape increases 400 times. Okay, team, I hope you found this insightful, helpful, useful, however you want to say it. I'm going to do that flip again. Woohoo! Okay, thanks a lot. Keep sending your questions and have a great day. Thank you. Hi, team. When I was little, I used to play tanagrams with my sister, and I found that it helped me understand geometric shapes, how the shape of a triangle compared to a larger triangle relates. Specifically with these similar shapes, I think the tanagrams will help you see that one small triangle is equal to two small triangles is equal to one medium triangle, and four small triangles is equal to one large triangle. Hope you found this helpful. Thank you.